Welcome to solving advent of code problems in F star. F star is a dependently typed language that lets you prove that properties about your program at the same time as you're writing it. Speaking of which, I wanted to show the solution to the thing that tripped me up last night. So, had a problem where I was trying to say that the forward function increments the horizontal direction. And I could only prove that if I eliminated the depth statement. And the reason that was the case is I had neglected to include this condition up here in the preconditions of the function. So we've got the arguments to the function here, and we put a condition on D that says it has to be greater than 0. This is the return type and the effect. And we can say these preconditions have to be true before we can call the function. And after we call the function, the ensures conditions are true. So the stateful reasoning in F star uses the state effect, which is based on a heap. So we just say, the two variables we need to be in the heap. And the important part I was missing is, and they're not the same variable. They're not pointers to the same location. They don't alias. Because if they did alias, then this function might not increase horizontal. It might decrease it because aim could be negative. It doesn't know. I didn't tell it couldn't be. And so when I put that in, then the function would finally type check. And this created a little bit of problems because the types of these global variables are not specific enough to say that they're not all aliases of each other. So I just put it in as an assumption in the start of the program. I think what's part of what's going on here is that this is not really the way you're supposed to do things, is have global variables and have these functions reference them. You're supposed to pass in the references in good functional fashion. So maybe there's some way to get around that. I tried a couple things, but they didn't work. But I was glad that I was able to, prove this fairly obvious thing that, hey, horizontal increases if you add a positive number to it. Even if you do something else in the meantime. So looking forward to what seemingly trivial thing will cause me problems today. That is part of the fun of learning the language. We've got about 1:30 to go. So thanks to everybody who showed up last night in a raid and got very confused. I also want to thank my employer, Akita Software, who is sponsoring Advent of Code this year. We are hiring. We'd love to have people who are interested in programming languages join our PL heavy group. But I'm a systems person by training, so we need back-end engineers, front-end engineers. We're looking for a developer advocate. I'd love to have you apply. There's a link in my on my stream page, or you go to Akita Software. If I can type, akitasoftware.com jobs. Got about 30 seconds to go. I am screen sharing. Not going to make the same mistake twice. I am trying a new chat front end that will give me a signal when somebody is chatting, so I won't ignore people for 20 minutes at a time either. All right, here we go. Hi, Gene. Yes, I heard that. Hi, Meyerdly. All right. parameter check is the power consumption. Okay, each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. So it's the majority function, majority bitwise function. Okay. So that gives us the gamma rate, which we convert to decimal. Okay, the epsilon rate is the least common bit, so the minority function. All right. So how big is our input? Pretty big. All right, I think we're gonna not just copy it in as a big input. We're actually gonna do some I/O today. All right, so why don't we start with that? Copy that, and I didn't get set up ahead of time. All right. All right. The module name has to be the same as the file name. It's not a very flexible system. Let's see, we're going to need I/O. We're going to need printf at some point. We're going to need probably list total. I don't know. Yeah, let's open that. And we're gonna need string. Okay, so we've got a bit vector type. Should I use the bit vector? Or is that gonna be completely... Okay, it's got the conversion functions, that's good. Map list of booleans to a bit vector, that's good. Does it have majority? It does not. All right, let's try using it anyway. Hello, Sir Skull Legend. So we're going to say, all right, so we're going to cheat and look at how long. I'm just going to do everything with length 12 because it'll tell me bits we got. All right, so type, what did they call this in the description? It's a diagnostic. Yes. Diagnostic equals bit vector. Okay, bit vector dot, it's BVT. BVT of 12. All right, does that all work? It does. All right, so let's write our function to parse a string into a bit vector. So I am I am learning to code in F star. It's a new language for me. I know plenty of other programming languages and work as a software engineer, but this is challenging to me because it's a research language out of Microsoft Research. It's got some rough edges, uh, and it's a stretch for me. Forces me to think about things in a different way. All right, so let's parse diagnostic. Let's take a string, and the string has to have. So this is a refinement type. We could just take a string, but we'll take only strings where the length of the string is 12. And that still doesn't guarantee that's correct. So we'll take an option type to either say, did it succeed or did it fail to parse? And I keep making this mistake. I think I need parentheses there. All right. So we should just be able to map. We should just be able to map a parse function across the list of characters, but then how would we tell if they were wrong? All right. I mean, we could say the string has to only contain two characters, but that would be the two characters we care about, but that would be a fairly complicated thing to express. All right, we'll just loosen up a little bit and say it. Oh, this was not a good choice. I can't type that word. All right, so parse bit given a single character becomes a Boolean. So if we did, so the match syntax lets us do pattern matching. Characters are pretty simple. No, it's just normal false. Confusingly, F star has two trues and two falses. It's got the Boolean value false and then the propositional type true. Okay, these are wrong. All right, now if we try that, it's going to complain that we didn't match all the characters. And it says the patterns are incomplete. The SMT solver couldn't prove that every character matched. So we could parse and put an error value all the way through, but we'll just say anything else is false. I don't know how to tell the autocomplete to go away. The Emacs mode is very helpful for some things, but other things I just haven't figured out yet. All right, so we should just call our list to BV. Oops. On map parse bit. So map the parse bit function over string. It's not string of to list. It's list of string. There it is. Yes. All right. Does that type check? Oh, length. All right. It does. It's happy that we it managed to reason that if we start with a string of length 12 and then we map it, then that list has the same length, and that's the one that lists to BV. So if we use the wrong value, it won't type check. It says, hey, I expected a list of length 12, and you just gave me some random list of pools. I'm sorry I can't make the bottom of the screen. All right. So what we're going to do is take I'm going to look at one of my previous attempts at I/O and copy that. So we don't actually care we don't care for part one what order these are in, since we're just doing the majority minority. So if we reverse it, that's fine. All right, so it's going to take a file descriptor that's open for reading, and sure, let's let's write it this way. So we're going to take a list of diagnostics and return so I switched effects here. These functions are both total, they always terminate, and they don't do any IO. ML is on the completely opposite side. A function with the ML effect marked can do IO, can fail to terminate, can throw exceptions, and we're gonna take full use of that. Except I didn't import that type. Reload our dependencies. Everything's good. Okay. Let rex means where it's recursive. The arrow is the wrong thing. That's for types. Okay. So one of the things I didn't find in the tutorial was how to catch exceptions, and it turns out it's the exactly like you do in ML. So in OCaml. So F star reads an awful lot like OCaml. It's got some extra stuff. But if you ever say I don't know how to do this, a good bet is look up how to do it on OCaml, which has much better tutorials, a lot more resources, and that'll give you the clue. So if we need to check this line has the right length. So if this length is not equal to 13, then we'll just fail. Otherwise, we want to parse the rest of the input and cons this onto the head of the list, which, as I said, will give us the wrong order, but that's okay. Parse. Okay, so there's a special character for cons. We'll use that. Okay. And then to find the end of file is signaled by an exception, which is not real convenient, but we'll just return the list we've been building up. And if it's any other error, then we'll fill with, all right, parse, I don't know why I said parse order, parse, there we go. Strlen of line. Oh, okay. Gotta check the right value. It said you gave me a line that wasn't a length 12. There we go. So it can tell that if we're in the else clause, then this must be true, and that's what we required parse diagnostic to get. So everything's happy there. All right, we could try this out. I'm fairly confident I haven't screwed up yet. So let's build our majority and minority functions on the list of bit vectors. How are we going to do this? All right, let's build something that takes a list of bools. If we're really fancy, we'd take the majority and minority at the same time. And let's try to write a fancy type, which is usually where I get in trouble. So this should be a Boolean, but it should be a special Boolean. Let me look at the list documentation a sec. So we have something that counts. It doesn't look like we have anything that counts the number. Okay, so I guess we build that first. So what I want to say is that the output should, so the number of B in input is greater than or equal to, I think it's greater than the length of the input divided by 2. So that's what the specification is. The thing that bothers me is, can we guarantee that it exists? And that's true only if the length of the list is odd. Otherwise, we could split 50-50. This is looking very complicated. Let's see how far we get. So we're gonna need a helper function that no, let's count them. All right, so let true count equals number of, we haven't written that yet, true in the input, and let the false count equals the number of false in the input. So we'll take two passes over, but all right. So if true greater than false count, then true, else false. So we could just do that. Sure. All right, so let's write the function we need. So number of, and we'll make it a general type, but it has to be a type that has equality. So a list of A's and the value that's A itself, and this returns a natural number. We should probably, if we're being rigorous, define that number, but we'll make do. So we're going to match the list, and let's be a little fancy here. So if the list is I don't know how to do this. What I want to match is the value that's in V. But I'm worried it will bind V to a new variable. All right, let's be less fancy. Okay. So if there's got to be a way to do that. I'm gonna check the tutorial a second. I put it. There are two tutorials. One that's not all the way written, and one that they've deprecated and made hard to find. Okay. Okay, those are all pretty simple. Yeah, we can match any. Is it copied from OCaml? It is. Okay, I mean, there's the pattern we saw. All right. Let's try it. See if it works. So the syntax is head, tail, when. That's a keyword. All right, looking good. When head equals V, then it's 1 plus the number of those in the rest of the list. And otherwise, it's just the number in the rest of the list. And if we reach the end, then it's 0. All right, let's see if it likes that. Okay. The pound says this is an we didn't define this recursive function. The pound says this is a aha. It says when clauses are not yet supported in verify mode, they will be someday. Oh dear. All right. I got to copy that for posterity. Okay. I do this the old-fashioned way. All right, if head equals v, single equal. F star also has 2 equals. I guess to JavaScript people, it's no big whoop. But it's got equals, which is an operator, and then that does equality comparison. Then it's got double equals, which is propositional equality, which is something you prove. So if it's single equals, it is also double equals, but not necessarily the reverse. All right. All right, that type checks. I keep forgetting the closing curly brace. Length input. Don't know why his Emacs has got itself in a bad way for that. Oh, what? Okay, it's using the wrong length. Both string and list define their own length functions. We gotta qualify it. If number, did I define this backwards? Yeah, I wanted to do it this way, and that'll number of that in that. And so what we're going to have to do to prove that this function terminates is say that each time we decrease the length. There we go. Okay. Okay. So it couldn't prove that this return type, which is bool, matches our fancy type. All right. So what do we need to prove that? So what, for one thing, it doesn't know that the true count and the false count I used double equals, I shouldn't have. I'm pretty sure it doesn't know that, as we haven't told it. Yeah, it says I can't prove that. So let's prove that. With a lemma. So a lemma is just a function in F star, but a funny function, not one that actually gets executed. So true and false partition the list. So given a list of bool, And it may be important that it's, and no, we don't, that's true even if it's even. All right, so we're going to say this is a lemma that ensures that number of true in L, number of false in L equals. All right, so how do we prove this? By induction. So if it's an empty list, then it's true. And we say the double paren is the unit value. It's just a singleton type. That's the only thing that has unit value. And in this context, it basically means figure it out yourself. So we'll check that it can actually number of. Check that actually. Okay, so it can figure that case out, and it says, well, if you prove it for the other case, then you've proved it in general. So all right. The easiest thing to do is just say, well, can you figure it out from the tail? Which we need to make this a recursive function. It can. All right, we're done. All we had to do is tell it, hey, you use induction, and you're done. It can reason from our definition of number of and the things it knows about lists. So we're good. All right. So now we can add this in as a lemma. Add it in like it's a function call about our input function. And so now that's all we needed. All right. Pretty cool. So S3 calls out to a SMT solver. It uses Z3, and that solver can prove things about simple arithmetic and about lists, and it doesn't actually do induction itself, but it can figure out what the inductive step. What if we give it this piece of information, it can say, based on that, can I prove the thing you wanted me to prove? Which is almost as good as it being able to do induction by itself. All right, so let's flip everything around here. And it's not happy. Be okay. So it might. Okay, we should. We need to. All right, if it's 5, then this should be 2. But length of input divided by 2. This is Euclidean division, so it should be. Oh, all right. It is less than or equal to. There we go. All right. Hurrah. So let's. All right, what were we actually trying to do? We're trying to count. We're trying to take our list and apply these to each bit. All right, so let's do that. So gamma on our list of diagnostic. Is that what it was called in the? Tot stands for total. That means it's a function. So I used it up here, to say this function is a total function. So it's defined on all its inputs. It always terminates. It doesn't have any side effects. So it's a pure and total function. The reason we have to use it here is because f star does not have effect polymorphism. So there's a bunch of list functions that work, like take map, and map has to be a total function. And there's a separate set that's list dot something else. What is it? Sorry, this is my homebrew. This is my homebrew documentation. I ran the documentation generator. I can't just go to the website. So there's another one which is just pure. So Tote says I'm using the one that works with total functions, not the ones that have a weaker condition. Okay. Okay, so we're going to take a list diagnostic and we're going to return an integer. And I'm going to do that by creating a new bit vector. Oh God, I'm not going to get into int ranges again. In my warm-up, I spent like days getting an int range function to work. We don't have to be general here. We can just hard code it. All right. So go back to bit vector. We're going to take what I want is a 12-way zip. I'm not sure that's going to happen. All right, but we can build this from the inside out. So we're going to build a new bit vector, and we're going to do list to BV on it. And that's going to be applying the majority function to all the 0th bits and then all the 1 bit. And then, okay, so we're going to do map. I'll just put in placeholder there, apply majority to everything. To the list, and this is where I'm being really cheesy. 12 numbers, yes. There's not a built-in range function. I was surprised, but so this is a list literal of the numbers 0 through 11 instead. Okay, so those are the index we want, and so for each index, we're going to take the majority of the list created by taking the ith element of everything in the list. So something, map something of yeah, just of L. Okay, so what's our something? I really should break this out. Let's break this out. What is this operation called? So all going to be ith element I. So let's, that seems like it should already have a name. I'm kind of surprised it doesn't. BV to int to BV, BV extension. Huh. Why doesn't this exist? Who knows? All right. So we've got a diagnostic and an integer I that is it's a natural number less than 12. We get a bool back, so we get the index not the string index, but the list index of, okay, what's that defined? That's defined as list first. So BV to list, what's it called? BV, yes, BV to list. Let's hear it for library consistency. Of DI. All right, does that work? That works. Does this work? Oh, we need to do it in the other order so we can curry the function. It's a little unfortunate. Oh, did again. Oh, okay. And then we need to take our bit vector and we need to turn it into an int. Okay, BV to int of all that. Wow, failed to. I'm gonna have to take a look at this. This may be where using bit vectors bites us. Failed to resolve implicit argument of type position introduced for flex quasi. Okay, so we can give it its implicit argument. So list to BV takes all right, its implicit argument is the length of the list. So its length is 12. Oh, we gotta say pound 12. Okay, we need to tell it that this list is odd, and then it will know the mapped list is also odd. So yes, this is not well defined. If list length L equals, okay. All right. it says it doesn't know that the list is 12 elements long, although it should. So what we're going to do is we're just going to prove it. So we're going to say 0 to 11 is a list of natural numbers, and the length, not var val, length of 0 to element equals 12. We might have to do a little more work. I guess we can't use the reuse the element name. I'm at 11. All right, here's what we're gonna do, is we're just gonna back that up, but we're going to ask it to prove via normalization, which just means expand the definitions until you're done. So list dot length of 11 okay, where's our syntax error? We didn't put the list back in. Okay, that's why we're getting the syntax error, because I deleted that. I should only stick with words I can actually type. I've had this problem with assert norm before. Is it check things, but it doesn't necessarily make them available. Gosh, I'm always surprised by what's the tough part of the night, and tonight is proving that the list has 12 elements in it. Okay. um. Right. What if we make it a function? It is actually equal to 12, right? Yeah. Okay. Wow. Maybe if increasing fuel would actually help here. So fuel is how many times it's willing to undo a recursive definition, but this should be fine. Because it should be all be given to the solver as one unit. All right, you know what? I've checked it twice. Even that's not enough. Wow. Am I gonna have to pull in int range just so I can define this? I mean, I got it to work eventually. All right, let's do 0 to n. And that returns a... I don't care what order they're in either. I do care what order. I have to preserve the order. Okay. I screwed this all up. All right. L is a list of nats such that n minus 1. Okay. So lists. All right. Match. All right. If n equals 1, then our list is 0. Else 0 to n1, n minus 1. I just feel like this is gonna bite us, because all right, let's just build it in reverse order, which will be easier for it to reason about, and then we can reverse it. Else n. All right, good. So let's call this 1 to 0. And then we want to reverse the order. Please tell me we have reverse. All these things you get used to just having, and then all right, there's a rev here somewhere. There we go. Reverse. Okay. Oh, we didn't call that anywhere. All right, it's not called anywhere. N minus 1 to 0 of 12. All right. And okay, so it's a list of. Oh, this is why I wanted to avoid this. Okay, so it's complaining that our list is not bounded by 12 like it needs to be. That the elements of the list are not themselves bounded. And so we could put in something here that says this is a list of numbers x such that x is less than n, but I don't think it's. Oh, it's telling us we got it wrong. The top number needs to be n minus 1. It says got type int, but it should know that if n is greater than 0 and it's not 0, okay, parentheses wrong. What am I missing here? Okay, if that's true, then n minus 1 is greater than or equal to 0, right? N sub 1 equals n minus 1 n. What? Okay, yeah, this is a problem I ran into before. That this list recursively has everything less than or equal to 1. And then, all right, fine. No, that's not it. Which one was it? Okay. It did all this work to prove that. Okay. This is so dumb. Why am I doing this? All right, so this is a bunch of lemmas to basically prove that everything's in the right range and it has the length that we expect it to have. All right, so let 0 to 11 which returns a list of numbers all of which are below 12. And that list has length 12. That range 0 to 12. Oh, L. All right, so this SMTP pat is supposed to say whenever you use this function, give this lemma so that you don't I have to specify it by default. Okay. All right. So is the problem that was the problem? Okay. I had used just like there are two types of equal and two types of lots of other things. There's all right. So is that enough to satisfy this function? Oh, so 11. We made it a function. All right, it works. We had to write 3 lemmas and 2 functions to prove that it list had the length that we gave it, but I don't know how to get the literal to work. This is ridiculous. There's got to be a better way to do this, but let's try to finish up part 1 because it's after midnight already. So this is the minority. Great. So I think we've got all the pieces. We wrote our parser. We wrote the 2 functions we're supposed to calculate. Let us write our main function then. Let's write a function that opens the file. So I'm going to take a file name, open the file for reading. Okay. Diagnostics is parse input of the file descriptor and the empty list. Let equals epsilon ts in. I don't think there's any way to define more than one thing in the same let statement, but maybe I just don't know what it is. ds in print string. We have to use the function op multiply unless we import a special package because star is reserved for pair types. Okay, so it says, how do you know that your input is of odd length like you promised? So we'll check it. So if list dot tote dot length ds mod 2 is not 1, then print else. All right. So it kept us honest. Let's compile this and try it out on the tutorial first, on the example first. So go back here. Oh no, does the tutorial have a different? It does have a different length. All right, we're just screwed. I'm not going back and fixing all that. So better hope this is right. I mean, we should have some confidence, right? It type checks. We asserted that it behaved the way it was expected to, so it's entirely possible I misunderstood the program, the problem, or misinterpreted something. Copy a makefile over. So f star is better save it. F star is rechecking everything that we checked interactively and writing out OCaml, and then we compile the OCaml file. And I made the same mistake I've made 2 nights in a row, which is that I didn't actually call this function we wrote. So calc part 1 of input.txt. Fortunately, the compilation is a little faster tonight than it was last night. Well, this is a stupid assumption for me to make. It's exactly 1,000 lines, so it's not guaranteed to have a majority, but it does anyway. Hmm. That's most unfortunate. I should have checked at the start. Uh, so let's see. If it's well defined, then adding a 0 at the end can't change anything. So this is a gross hack. The only way it matters is if there's even values, but if there's even numbers, then it doesn't matter. Then the problem is not well defined. Okay. If we just charged ahead without writing any types, then we wouldn't be in this situation. Let's see if we're okay. All right. That's the right answer. All right. On to part 2. All right. So we're going to filter by the most common value. That's going to cause us even more grief because we could have sublists that are of even length. And so our function can't guarantee that. Okay, so we're gonna have to loosen our specification. We're just gonna have to say if it's evenly matched, then it's we pick a value arbitrarily. So we'll get rid of that constraint and change the module name. Okay, good. Still type checked. Minority is less than or equal to. Okay, good, good. All right, so let me check this again. So we're going to, if 0 and 1 are equally common, keep values with a 1. All right, so this is where this might actually be helpful. So we can encode that as a type. And it's easy to get wrong. So it's worth doing. So we can say either it's greater than the input length via 2 or B is true and number of true equals two and one are equally common, and the least common we need to go the other way. All right, number of true input, number of B true. Why is it on O underscore? All right. So is the subcheck, is it failing for a dumb reason or because we didn't actually do this? Oh, we didn't actually do it. Right, because we only got. Okay, we should use the other or. All right, so this should be greater than or equal to make that true. Good. That's helpful. It's the first time we've actually gotten, I think, some mileage out of this. All right, so we say this is true is I mean, we'd really only like to have this come into play for odd numbers. I think it didn't matter too much on the other one. But let's all right, so it should be less than half rounded up, or it should be false, and the number of falses is exactly. Okay. Okay. I'm feeling pretty good. So let's define the filter criteria. Be easier if we could loop. Okay, so all right, so let's say we're going to filter by position I, and I is a natural number less than 12. And we're going to take uh, we're going to take the list of diagnostic, and we're going to return a list of another list of diagnostic, which, I mean, we could show that it's non-empty, but that would be really gross, I think. Okay, so let um, okay, take everything, take the ith element of the bit vector across everything, take the majority of that. Okay, good. This filter removes everything where fx does not hold removed. Okay, so filter ith element for each diagnostic, the ith element of D has to be equal to bit. Okay. And we need the same for minority. Good. Okay, so we need to go from, is it from first, yeah, from first bit to the last bit. So this returns an integer. So if n equals 12, then we can't do this anymore. We'll say greater than or equal to 12 to make it easier on the solver, then just return an error value. You should probably make this an option int, but it's fine. Else, if equals 1, then we just do bv2 int that. Else we recursively call with n plus 1. And we can't really put the condition that n is less than 12 because how do we prove that it actually terminates? It might not on some inputs. So it's kind of sketchy, but I don't see a way to do better here. So we're gonna filter majority by position n, which we know is less than 12 at this point in the control flow of the list. Extra colon. Wrong equality, wrong syntax. Can you tell I've been programming Python today? So we need to do list to BV. Oh no, we need to grab the first element of the list. That's not right. Head. So this decreases 12 minus n. It doesn't decrease n. But we need to prove. Okay, we need to prove that the function terminates. Maybe we should do. Oh no, we circle all the way around. Okay, that's all right. I mean, crud. I should have more confidence that if it type checks, then it will terminate. That's what it was yelling at me before about. Okay, so that's O2, and the CO2 is the same thing with the minority. And, you know, if we were cool functional programmers, we'd have abstracted this operation across the filtering criteria, which we could do, but all right, let's get rid of our hack. Let's get O2 starting at 0 and CO2 starting at 0. All right. Having type checks, let's try it out. Not as confident we got everything right. Nope. Nope. Something's wrong. All right. Double check. All right. First bit. Okay. All right. We can get rid of all this stuff. Don't need that anymore. So it seems likely that if there's a problem, we screwed up the definition of majority minority. But I spent some time writing these conditions, and I kind of believe they're correct. And they type checked, so so let's write some unit tests. So we believe that majority of one false, true equals true. Oh, that's the wrong syntax. That's tuple syntax, not list syntax. Okay. Looks good. This should be false, and this should. Is that what it says? When you're looking for the minority, yeah, we want to keep values that have a 0. Okay, so we didn't screw up on the parity. We did screw up on the parity. Oh no. Nope. That's the right thing. No, that's a bad test case. All right. Hmm. Well, so let's write. Let's use the example input and just extend it out. That's 5 bits, so we need 1, 2, 3, 4, 5, 6, 7 more. Except the value is going to be off by a factor of 2 to the 7th. Oh, the problem was that I ran part 1 again. Getting tired, I guess. All right, let's try running the part 2 code on the real input. Okay, that's not so good. But at least we're running the right program now. Seven, 6, 8, 3, 2, 5, 7th. 230. Okay, so we're correct on the example. And we're just getting a 0 on the big one, which is telling us that probably that we're hitting this case. Let's put something more. All right. If we reach there, then we return the none type, otherwise we return the sum type. Okay, so at V1 with I'm running out of letters. All right, so okay, match S2 with non next. Interesting. Okay, so it's our majority. Yeah, one of these is not doing the right thing. The majority I'm pretty confident in now. We both proved it and unit tested it. So I don't think we're doing anything silly there. A small test case worked okay. All right, we'll make this a non-total function so we can print out what is our length at the end. Uh, Nobody in the chat is jumping up and saying, I know where the bug is. Oh, okay. That makes sense. We should just check these in the opposite order. We got all the way down to 1 on the very last bit. So it was a bounds check. It's a good, how could we write a type for this that would have caught that? I don't know. Else if it's good, all looks good, let's make part 2. Hurrah! Okay. It only took me an hour and 45 minutes tonight, so about a half hour longer than last night. That's not a good trend, but we did it. Thanks for staying up with me. I'm going to call it a night, unless there are any questions. I didn't see any in the chat beyond what does tote stand for, which I explained. So, have a good rest of your evening.